Hello, I'm Pramit Kumar Senapati. I'm going to explain about the importance of computational methods, that is finite element analysis and many other solutions available in industry, and why the industry is approaching towards this solution, that is finite element analysis, the reason behind this particular method, and also we will be looking into different verticals and the applications the industry is adopting, and we can say the growing industry and other OEMs, how they are using these solutions, and we will be looking into the gap between our current education system, that you can say the curriculum, and the industry requirement. In order to bridge the gap, what exactly we need to do, and also what exactly is the expectation in our growing industry. If you see any complex problem, there you cannot directly say that what all load conditions are there, in what condition this particular model, maybe assembly, maybe any machine can fail, what all different failure criteria are there. So various plugins or cases we need to link to our model in order to understand the practical failure response and cases. Then only we can say that our particular machine or component can withstand a particular given load conditions, maybe in form of vibration, maybe in form of contact stress, maybe in form of static stress, maybe in the form of the temperature gradient, and literally anything. But if you look into our engineering domain, basically I mean to say the syllabus or the curriculum which we go through in our education system, in our B.Tech or BE mechanical streams. So you have to understand what exactly industry is using and what we have the domain knowledge. If you see strength of material, theory of machine design, failure theories, and many other domains like thermodynamics and heat transfer, when collectively you think about a practical problem, there you see applications of all these various subjects, and you need to apply all the theories over the domain in order to address or in order to predict the failure criteria. For example, let us talk about a automotive engine. Everybody they know that if you talk about engine, the engine generates the power, and that power system is connected to the transmission, and that transmission is connected to the road wheels. If you see only the engine is the power generating system, you need to understand practically when you apply, and in order to study the conditions, you need to see the road test, the various tests you need to execute in order to understand what all load factors are transferred through the chassis or through your suspension system to your engine domain. And apart from that, if you only study the engineering domain, that is the engine, there only you have the motion, where you see the stress concentration and stress distribution, maybe strains, and also the thermal response figure of the combustion. And only if you see engine, there you have also the cooling mechanism through the jackets. So collectively, if you need to understand the response, you need to plug in all the individual cases one by one. Otherwise, what happens is you predict something and you are expecting something. That means there will be a gap between your practical response and your theory response. So this gap you need to address in our engineering curriculum, and we need to prepare our future student what industry exactly is requiring. This is very important aspect as far as the industry is concerned, and we are the young generation, and we need to understand the broad scenario and the response what industry is using. Maybe you talk about auto domain, all the auto segments, maybe from the two-wheelers, four-wheelers to heavy equipment. Maybe we are talking about aerospace industry. Maybe you can talk about any consumer products. I'm not talking about toys and all where you have very low accuracy involved only for just for the selling purpose. We can manufacture this where you don't have the tolerance and geometric dimension and high-end tolerance involvement. But typically the range of product, when you talk about mobile device, when you talk about any electronic warfare equipment, where you have high sensitive response over the failure. If you talk about any design, if you directly see that I'll go for over design, or you are going for a under design, both are not good as far as the manufacturing concerned, as far as the cost factor is concerned, as far as the reliability factor is concerned. We have to go for the correct design aspect ratio, maybe 1.4, maybe 5, maybe 10. But how do we justify the factor of safety and the conditions which we collaborate, which we integrate, which we synchronously understand that what would be the best factor of safety? Only if you consider the static condition, primarily you talk about the various load conditions which are known, but in case of dynamic, many unknown factors that you need to consider, and also the failure response you need to predict by aligning all those aspects, conditions and various other loading states. So if you see the type of analysis, starting from the static, from the multiphysics, starting from the thermal, from the magnetic, motion simulations and various other domain, if you talk about the computational fluid dynamics, CFD, and now the research is going on in meshless method. Primarily in finite element analysis we use mesh method, where we discretize or divide the physical model to finite model or mathematical model by dividing into small segment. So we used to offer to engineering student the live industrial example by using the finite element analysis technique, so that they can understand what exactly industry is using, and also they can fulfill their academic credential and whatever the requirement the university is giving. So each year we release, the Mitsu CAD/CAM Solutions Private Limited releases nearly 500 to 1000 latest industrial domain projects for the B.Tech and M.Tech mechanical engineering students. So you can also check the details and understand, and you can always there to help our students. Thank you.